All right, guys. So we're going to talk about finding rational zeros using the rational zeros theorem. There's different types, of course, that we have on our homework, but we're going to talk about problem type 2. Now, I'm not sure how Alex explains this. Some textbooks break this down a little bit differently, but this is how I do this. I am going to label this. There's an incorrect answer here, and that's fine. I just took a screenshot of what was in front of me. But I'm going to label this as my P, and I'm going to label this as my Q. So what I do is I take those terms and those numbers, and I make fractions P over Q to begin with. What I see is that I have a 6 over 3. Now, I'm not worried about that minus the negative on that 3, because if you go back and you look at your notes and you look at what was taught to you, when you go to find these rational roots, we always include the positive and the negative rational root. So the sign doesn't matter. We're just going to look at the number itself. Now, the P and the Q, when I wrote it like that, that is just the term there. But what I have to do is I have to, let's make a note, we have to find factors of each. Now, this might be unconventional, but what I literally do is I make a large fraction bar and I write down all the factors of 6 on top. So for me, I know that 6 is divisible by 6, it is divisible by 3, it is divisible by 2, and it is divisible by 1. Now, again, remember, this is always going to be plus and minus, but I'm going to put that at the end just to save me time and keep from making this look like a mess. I'm just going to leave the plus and minus off until the very end. My factors of 3 include 3 and 1. And so from there, what I do is I write down all of my possible ratios, if we want to use that word. So I can see that I could have 6 divisible by 3 and 6 divisible by 1. And if I choose to color coordinate this, I can do 3 divisible by 3 and 3 divisible by 1. I can have 2 divisible by 3 and 2 divisible by 1. And we will just keep this last one black. That will give me 1 divisible by 3 and 1 divisible by 1. Now, I want you to be careful. I can't leave that as my answer, because if you look up top, I think it says somewhere, it does, I'm going to highlight this, be sure that no value in your list appears more than once. Now, nothing in this list appears more than once, in this form, in the same form. But let's simplify this. Let's take and simplify what I have. 6 divided by 3 is 2. 6 divided by 1 is 6. 3 divided by 3 is 1. 3 divided by 1 is 3. 2, that's just going to be 2/3. 2 divided by 1 is 2. 1 divided by 3 is 1/3, and 1 divided by 1 is 1. So now we can see how I have a 2 and a 2 that's repeated. If I change my color, you can see that I have 1 and 1 that's repeated. And that's pretty much it. So I have my possible rational roots. That does not mean that all of these are rational roots. These are places where roots could occur. And at this point, I've got to make a note to remember to add our positive and negative signs to our rationals here. So I'm going to start with positive and negative 1/3, and I'm just going to cross this off so I don't forget. I have positive and negative 2/3. I have, and let's just go in order. I have number 1. I have the number 2. And I have the number 3 and number 6. And again, I almost forgot myself to add my positive and negatives. And that, if you look up top, is my answers. But what they did is they started with 1, 2, 3, and 6, and then they wrote the 1/3 and the 2/3, but that does not matter. As long as you have them there, you would get correct. You would get it scored correctly. And that's it. So that's how we got our answer. I hope this helps.